Chances are you used one just this morning and probably didn't give it a second thought. But what if I told you that that simple flight of stairs is actually a masterpiece of design, something perfected over centuries? Well, today, we're going to uncover the hidden genius of the simple staircase.
I mean, seriously, have you ever just stopped and really looked at a staircase? Because it's so much more than just a way to get from point A to point B. It's kind of like this amazing puzzle, right? A mix of physics and human anatomy, where every single angle, every single dimension has been carefully calculated for our safety and comfort.
What you're looking at here is basically a collection of really specialized parts. You've got the tread, the riser, the stringer, and they're all working in perfect harmony. See, each little component has a very specific job, and if just one of them fails, well, the whole system can become pretty unsafe pretty fast.
Okay, so before we start taking it apart, piece by piece, let's just ask a really basic question. Why do we even have stairs? I mean, why do they exist? It turns out they actually serve two super vital and very different purposes in pretty much any building. So, on the one hand, you've got the everyday function, right? Access. They just connect our world, they make multi-story buildings even possible. But then, on the other, and I'd say more critical hand, you have escape. Think about it. When the alarms are blaring and the elevators are shut down, a staircase becomes your lifeline. It's that clear, reliable path to safety.
All right, let's start breaking this down. To really get what makes a staircase tick, we have to start with the most fundamental part of all, the step itself. This is literally where the rubber, or, your shoe, meets the road.
So this flat surface you see here, that's called the tread. And it seems so simple, right? But its depth, its material, absolutely crucial. If it's too shallow, your foot's going to hang off the edge. If it's too slippery, well, that's a huge hazard. The real genius is in making it just right for the average person's foot.
And then you have this vertical piece. That's the riser. Its whole job is just to give height to each step. And honestly, the relationship between the tread you step on and the riser that lifts you up, that is the absolute core of all staircase design.
Okay, this is where the real magic happens. You have the vertical rise and the horizontal run, and they have to be in this perfect relationship. I mean, just think about it for a second. If the rise is way too high, it feels like you're rock climbing, right? And if the run is too short, you're forced to take these tiny, awkward little steps. There's a reason building codes have super strict rules for this ratio. It's all to make sure every step feels natural and safe.
But, a stack of steps is, well, it's just a stack of steps. So what actually turns it into a proper staircase? That's where the support system comes in. Think of it as the skeleton that holds everything together and the safety net that keeps us from falling.
Okay, this is the stringer. And let me tell you, it is the absolute backbone of the entire structure. It's that big diagonal beam that carries all the weight, your weight, the weight of the steps, everything. Without the stringer, you would literally just have a pile of wood on the floor.
And what anchors that whole safety system, that would be the newel post. It's that big, sturdy post you always see at the beginning and the end of the stairs, or maybe at a corner. It's the cornerstone that the handrail connects to, and it provides all the stability for the whole railing.
And then, of course, there's the handrail. We all know this one. It's our physical and I'd even say psychological safety net. We just instinctively reach for it to get our balance. That simple rail has probably prevented countless falls, and it is an absolutely non-negotiable part of staircase safety. Now these vertical bars here, these are the balusters. And they do a lot more than just hold up the handrail. They actually create a safety wall. And that's exactly why building codes are so specific about how far apart they can be. It's all designed to prevent a small child from being able to slip through.
And finally, one you might not think about, headroom. Have you ever walked up a basement staircase and had to duck your head? Yep, that's bad headroom. It's basically the minimum vertical space you need to make sure you can walk up and down comfortably without, getting a concussion.
So we have all these individual parts, right? We've got the treads, the risers, the stringers, the handrails. But the thing is, they don't work in isolation. Not at all. So let's zoom out a bit and see how they all come together to create one single harmonious system. It really just boils down to this. The tread, that's where you step. The riser, that's what lifts you up. The stringer is the muscle holding everything together. And the handrail, that's the guardian keeping you safe. 4 simple functions, all working together in one elegant system.
This diagram really shows it all in action. You can see exactly how the stringer acts as the foundation for the whole thing, how the treads and risers are slotted right into it, and how the entire handrail assembly, which is anchored by that newel post, creates this kind of protective cage around you. Every single piece connects to another. Trust me, nothing here is an accident.
And really, it all comes down to these three core principles. It has to be safe, so you don't fall, it has to be strong, so it doesn't collapse under you, and it has to be easy to use, so that the climb feels natural, not like some exhausting chore. Every single design choice serves one of these three masters.
So here's my challenge to you. The next time you take the stairs, just pause for a second and really look. See the whole system. Notice the balance between the rise and the run. Appreciate that hidden stringer doing all the heavy lifting. You're not just climbing steps anymore. You're using a perfectly engineered machine. So what new details are you going to see?